So I'm going to talk about Polka, which is a block explorer for Substrate. And I'm going to go into some specifics that are particular to Polka. So first of all, I'm going to start a bit about what Polka is and what it does. I'm going to go into some specifics of Substrate, the Substrate Runtime, and I guess I'm kind of aiming for an audience of future Substrate implementers. I guess I have some best practices for Substrate implementers to ensure optimal compatibility with a Polka in the future, and I'll go a bit into our roadmap. So basically, we want to make the multi-chain data accessible and understandable. That's our mission. Well, we predict a future that will have many chains built with only a few frameworks. And well, obviously, we think that Substrate is one of these frameworks that allows for that. But you get into, well, increasing specialization. You need quite a lot of skills to actually start working with that. And I think what you see a lot in new industries is that you get some sort of outsourcing with that. So specialized organizations will emerge to do service management or of block explorers, for example. So Polka is our multi-chain block explorer, and Web3 is the organization I work for, and we intend to be one of these service providers doing full service stuff for block explorers. So what has always interested me is the data. I've been building block explorers well, since 2015. Especially Ethereum got me interested in that, and there's some data you can easily get out of nodes, and well, lots of the interesting stuff that's actually really hard to get out of nodes, and especially if you want to search for stuff that's happening on a blockchain, or if you want to go into some sort of aggregation or statistics or correlations, or get the full history, then not only the configuration of your node is important, but you get into what block explorers came to be. With Polka we try to do all that stuff that's on the right-hand side, and we try to do that not only for a single chain, but for multiple chains as well. Basically, the model of our block explorer is you have a data source, such as a node, which has an API. We have a harvester application, which does nothing more than get as much data out in a systematic way. It puts it in a general storage, which is a large database. These databases can grow up to 10 terabytes, for example. We put an API on top of that, and we put a user interface on top of that. The idea with a multi-chain explorer is that you have all these harvesters and blockchains in parallel, but we put a single user interface on top, so you can get access to all these different blockchains through a single UI, and that's where we get into Web3, the service provider. I can imagine a future where you do all sorts of data integration, service level management, quality assurance on that data layer for organizations interested in that. So the idea for Polka is if we can build one generalized block explorer stack for Substrate, we can have block explorers for all the chains that will emerge in the Polka Dot Ecosystem. Well, these are a number of projects that are currently in that Polka Dot ecosystem already, and I bet that that number will grow. Well, these are a few of these. This is an example of an image of how a single relay chain composes an ecosystem. You have well, many specialized chains. There are multiple nesting levels, and even if one level only has 100 chains, for example, a second level could have another 100 chains. You could get to an ecosystem of, say, 10,000 chains. Won't go that fast, and we won't get there very soon, but this is the general direction. This is one of the images from Jack's recent article about the Polka Dot ecosystem. I call this a Polka Dot universe. Basically, one relay chain interconnecting all these different blockchains in one such universe, and all these lines between these blockchains. That's the interoperability, or should represent the interoperability. I guess what we're trying to build is one single block explorer for such Polka Dot universe. I want to talk a bit about the Substrate Runtime, which makes everything we're doing possible. So we've heard a couple of times before already today that Substrate is a development framework for blockchains. And with Substrate, you can build different classes of blockchains, from Bitcoin-like UTXO classes of blockchains to full smart contract blockchains to single or dual function blockchains, of which the Polka Dot relay chain is an example. Or the Ethereum 2 Jasper specification is being built as a such single function blockchain on Substrate. And we've heard in Rob Habermeyer's talk about how light clients can be built of different chains within other chains. So that these are all these different functions you can build with Substrate. And basically, Substrate consists of a number of layers, and the only difference between the chains built with Substrate is the runtime. The runtime is what defines, what differentiates one chain from another. So the thing is that Substrate is really abstract. It needs to be abstract if you want to be able to do anything with it. But if you want to build block explorers, then you really want to talk about meaningful data, stuff, you know, transactions, tokens, balances, accounts. All these things don't exist in Substrate, in vanilla Substrate. You only have blocks, extrinsics, and storage. An extrinsic is a general term for a transaction, but it doesn't have any meaning. It just looks like a blob or a string of bytes. And there is storage, that's so, and all the stuff that is stored within the blockchain. The extrinsics is the stuff that triggers the state changes within the blockchains, and the blocks themselves, they are not really more than an ordering mechanism. So to tell what comes first and what comes next. So Substrate doesn't even have accounts. It doesn't have timestamps. It has nothing. And all the data that is stored in the runtime has there's no decoding context for that. So, and that is a problem if you want to build a block explorer for that type of technology. But there's a good thing. A runtime, that part that defines what the blockchain does, has an API, or the metadata. So that's one of these things that Substrate provides, and it gives you the decoding context. So I'll give an outline of the 5 components of that metadata, and it gives you an idea of what your runtime does. So we've heard this a couple of times before as well. SRML, Substrate Runtime Module Libraries. These are basically logical groups within the Substrate runtime. So we can see that there is a runtime module for accounts, for balances, for treasury, even for smart contracts. So if your Substrate runtime is built with the contracts module, then your Substrate chain you built has smart contract support. Well, and these modules have a number of special functions in them. One is call functions. These are basically, they define what your blockchain can do. So you can call these from the outside, and you could look at them as your transaction types. So you could input a transaction, you could send a transaction of a certain type to the blockchain, which is a transfer type transaction. And you can give an address, which is the recipient of that transaction, and a balance, and that type of transaction would allow you to transfer something. But again, this is not a native function of Substrate, because Substrate has no native function. This is one function which is part of this one particular runtime module, which is built by Parity in this case, or and I guess this function exists on the Polka Dot relay chain as well, because you need to be able to transfer your dots from one account to another. Well, and you can have tens or hundreds of different transaction types, and these are the call functions, and the metadata, the ABI of the runtime, will allow you to identify and decode these type of transactions. So what this means for a block explorer is that if you harvest the data from your block explorer, you can classify the transactions by mapping them to the metadata specification you get from Substrate. And you can list, for example, all the balance transfer transactions of this particular blockchain, which makes your block explorer generic. Another chain would perhaps not have such a function, and your block explorer would not show that part. Well, another component of the runtime are storage functions. Basically, it allows you to query the state of the blockchain using the metadata. If you don't have that metadata, you don't know what to query for. It's a bit like having a smart contract without the ABI. You wouldn't know where to start looking. Yes, there's one special storage container. It's called events. I guess you could compare that to the logs you have in Ethereum. You can use these as a cheap or effective notification of a state transition if you build the triggers for these events into your runtime. One example, you could use a storage function to query for changes, but you would really need to monitor the things you're looking for. Events, these are fired when stuff happens or stuff changes, so you don't have to pull for stuff every block, but you know when to check the storage. One important component of the Substrate Runtime metadata definition is that there is a type definition and type composition. If I go back a number of pages, you see all the pink words. These are basically data types, an address, a balance, a referendum index or a vote, a balance, an account ID, and so on. These types have a meaning and a composition, and there's some improvement, I guess, here. There could be some improvement still here, but all the data types, what you get from a substrate node is nothing more than a byte representation. These data type definitions really help you how to interpret the bytes. So if you know that your thing maps to an unsigned 32 integer, you know that you have 32 bits to scrape from that string and to go to the interpretation and the meaning of that. Since all types are nicely defined in the substrate runtime, that allows a very nice low-level mechanism to get meaningful data of higher-level objects in your block explorer. Yes. So the runtime's ABI promotes substrate second-class citizens to first-class citizens in PolkaScan. So, as I said, substrate only has a handful of first-class citizens: blocks, extrinsics, and, well, storage. You can't do anything with that in a block explorer. All the interesting stuff is within the runtime. So it's the accounts, the balances, the votes, the proposals that are voted on. These are all second-class citizens in Substrate, but you want to have these meaningful data entities in your block explorer. That's the stuff you would want to know. That's why you interact with a blockchain, to get that meaning out of it. So we have been prototyping PolkaScan and the harvester, and we have been compiling the Substrate nodes for many of the projects that were in the image before, and well, there are some things that help compatibility for with PolkaScan. So one of these things, for example, this is perhaps a 101 on how to deal with GitHub, but that I'm talking to Substrate implementers now, that change and release management procedures are, well, are followed or whatsoever. This is, even at parity, sometimes it goes wrong because we're looking at version 03.15, but the cargo files are still on a different version number. So there should be, well, some sort of process for that. It helps if these things are sorted. Then there is the version change release management for the runtimes themselves. Substrate has this great feature that the runtimes, that what defines what the blockchain is and does, that it can be upgraded through on-chain governance. But there again, it is important to have good release management practices for that. Well, I think we've seen many examples already today of these runtime modules that are being developed by different teams. Some runtime modules, I guess, will become standard modules or go-to modules. If you want an account token module, I think we will see that there will be some convergence on some standards with that. I think it makes sense to reuse runtime modules where possible and not go, you know, invent it all again. Well, you should be careful when you introduce new structs or type definitions. One of the things we learned, for example, in building our first proof of concepts is that what the balance type actually means can change with runtime upgrades, and this is problematic. It really makes a difference if you scrape 64 bits or 128 bits because, well, you just don't know where the meaning of your byte string or bit string stops and where the next section starts. So I guess it would be good for the ecosystem to come up with some sort of registry of reserved words of some kind, and perhaps Polkas can be that resource for a while at least, until we address these type of problems. I've told you about these events which are triggered, can be triggered when an important state change happens. I guess in our designs and our prototypes of PolkaScan, we came to rely on these events heavily, and we will be indexing all the events that are fired in any substrate we support, and that allows for indexes and lookups on data that is provided in these events. And basically it means if you fire an event for every new account that is created, you get a search function in your block explorer for all the accounts. If you create an event in your runtime for all the balance transfers, which have a recipient, a sender, and a balance and a transaction fee perhaps, then because we are indexing these components, you can get lists of what the largest transactions are in an ascending or descending order, or you can look up all the different transfers from a specific account or to a specific account, because we've built these indexes based on these data structures. Well, and perhaps a non-technical best practice is for all these organizations and companies and individuals in this new emerging Polka Dot ecosystem to get to know each other, to be aware of each other, and well, to work on relationships. There's lots of synergies possible, and for starters, we would like to get in touch with all Substrate implementers so we can maximize our compatibility with all these new changes that are emerging. So roadmap. So I spent most of, I think, 10 months now researching how to build a multi-chain explorer on Substrate. That research is done. We have applied for an ecosystem grant. Well, if that works out, we will be providing the community with an open source solo chain explorer, which is the entire stack for one single Substrate chain. And our business activities, the Web3 scan activities, will continue in building the multi-chain explorer and services around that. Thank you. That's it for now. One more thing. This is the polkascan.io. There has been some hostility, and our website was DDoSed, so not everything is up and running right now, but hang tight. In a few days that will be solved. So if you want to talk to me, reach out, come find me. Yeah, so how are we with time? Yeah. There's a question, right? Yeah. Who has the second mic?
Where was the question? Oh.
It's just a quick question. Hey, thank you for the talk. One question. So for substrate chains that have included the contracts module, so support smart contracts, are you also, I guess that's kind of like an extra layer of sort of indirection or depth in terms of having a block explorer that can understand smart contracts deployed onto a substrate chain? Is that something you're also looking at or planning on dealing with?
Yes. Well, the first test nets have been deployed with that support, but I don't really know what that looks like yet. Okay. So I bet, for starters, that if a smart contract is deployed, like on Ethereum, a good runtime design would trigger the firing of a contract created event of some kind. And it would have some meaningful data, for example, at least to allow the block explorer to identify and list the smart contracts that have been deployed. But when you talk about interaction with the smart contract itself, I guess that's just another layer of building such a codec, which we have for the runtime, but then for the contracts themselves.
Yeah, that makes sense. And I guess usually the ABI, I guess,
yeah,
in the way the Ethereum, the ABI for a smart contract is not kind of provided by the chain itself. Right? It would have to be provided somewhat independently by the
I guess because in an open system, anyone could deploy the bytecode of a smart contract.
Yeah.
And I'm not aware of the details of these processes yet. It's just really early in this ecosystem, and I bet that the Edgeware project, which are relying heavily on that runtime module for their smart contract and governance platform, that as soon as we start interacting with them more, that more details will follow.
Thank you.
Yeah. Anyone else?
Any other questions for Emiel? Here we go.
Hello. So, do you think that could be interesting in some point to start thinking how to embed some visualizers in Substrate, like in a way that Polka scan or Web3 scan can show some transaction data? So it's just embedding some kind of very basic visualization of transactions. So in terms that it can be rendered in the user interface when you access to this transaction. So it's just embedding some visualization.
I have difficulty understanding your question.
No, it's just for instance in Ethereum now the problem is internal transactions. Sometimes it's very hard to trace, yeah?
Yes.
Because maybe you don't know exactly what's that. But if in some point, for instance, in a smart contract, we give some way to, you could visualize this transaction in this way in Etherscan, for instance. It'd be easier for users to understand what's happening with their transactions. Do you think that these kind of things could be useful also?
If your question is, I've built an EVM block explorer, so I'm well aware of what makes it difficult and usable. And in Etherscan, they introduced the term internal transactions which is all the stuff that is triggered by the contract themselves, or triggered by transactions.
Just for instance, when I am using an application, I need to trust in this application. And this
talk to me afterwards. I can't understand your question. I have difficulty understanding.
Okay, I will ask you later.
Okay. Sorry.
All right. So thank you so much, Emiel.